I'm Mercury Joel, and today we're discussing 63, 64 Mercuries. We have a beautiful day. We're under a shade tree. We aren't called shade tree mechanics, but what we're going to talk about today is a problem that 63 and 64 Mercuries had, and you should be aware of it because it's not if it happens, because it's going to happen. Guaranteed, this will happen. 63 was the first year Mercury went with an alternator. The big car Mercuries had them. The Comets and whatnot still ran generators on their smaller engines. Anyway, for the first 2 years, 63 and 4, they used an alternator. Now, I can't tell you the name brand, but it was the only 2 years they used it. And they had a special hookup like all alternators do. 65 on up went with this style of alternator where you had 3 separate wires you bolted on. This has kind of a plug-in deal here that you bolt on. An alternator was great over the generator in the fact that it could generate electricity at a much slower RPM and more amps, faster, quicker. You could park with your girlfriend in the winter time with the heater on and the radio on and not run your battery down. Alternator was a blessing. Alternator stands for alternating current. Generator produced a DC, direct current. In the alternator, we have to convert alternating current to direct current. It requires a diode to do this. A diode is a check valve. In other words, let me back up here. When your big brother that you looked up to said, gee, why don't you put your finger in this light socket and see what happens? And of course, you admired your big brother. So you put your finger in the light socket and you got this vibrating pulse like that. That's the alternating current. The current goes through the wire like this. It alternates back and forth. Automobiles use direct current. Current flows one direction. That's what the diodes do. They are like a check valve. They allow it to go this way but not back. So you get a direct current. The diodes, meaning the check valves, in this brand of alternator, had a habit of separating from their plate. There's 3 diodes on 3 on one plate, like a positive plate, 3 on a negative plate. The newer alternators, 65 and up, the diodes were pressed into a plate, so they stayed put. On the older ones, on this brand of alternator, they were actually soldered to a plate. As the alternator gets old, like we all, they get a little slow and tired. They create heat. The heat allows the solder to melt, which allows the diode to fall away from its plate, therefore touching whatever it should not be touching. And it creates a dead short. And here is where the problem comes in. If you'll notice here, this big 10 gauge wire here is what carries the juice. That's what takes electricity that the alternator is making and puts it into the automobile battery. Now, we want the convenience of knowing how this alternator is working. Thus, we have the gauge cluster, as we're all familiar with, 63, 64 Mercury gauge cluster. And you will notice fuel, oil, there's your alternator, and your temp. The alternator is an actual amp gauge in which it requires the main wire carrying the current to go through this loop. Galen, I don't know if you can pan in on this loop that's on the back of the gauge. You'll see this even on the older Mercuries. Clear back to your 49s. They had this loop. Okay, this big wire here, this big wire right here, going through this loop. That's the back side of the gauge, okay? All right. That is how this gauge reads what the alternator is putting into the battery. So in other words, we have the alternator and the battery, and the gauge is in the middle. Alternator here, you have your battery here.
Yes.
Alternator is putting current into the battery, but to do that, the amp meter is between them. So the wire is going from the alternator through this amp gauge loop to the battery. And when this is happening and the current's going this direction to the battery, it's showing a charge. That's when this beautiful little needle here comes over to the C. That's what we want to see, all right? When something happens that, let's say, the alternator dies, it's no longer producing energy or electricity, your car is demanding electricity, now the current is coming from the battery back into the vehicle this way, and we show a discharge. That's what the D is for, okay? Right there on the gauge. And it reads all of that very simply through this big wire. Right here on the gauge, there's the loop right there.
How do I know what wire it is that goes through that?
That's a big wire.
10 gauge wire.
10 gauge wire. Now if you want to take your panel out of the car, don't go up there with the side cutters and cut this wire. You'll regret doing that. And don't try to bend or break or open this loop up, because you'll wreck your gauge. Okay, that's why Mercury put in this handy dandy connector here. And it's hard to unplug out here on the workbench. Just think how much fun it's going to be under the dash. But you can unplug that and thread this wire back through that loop, and that will free you of the harness. Okay, the battery would be right here. This is hooked to the starter solenoid on your left fender. I'll show you on my pink Merc when we're done.
So the power comes from the battery.
Its power is supposed to go from the alternator through the gauge, through the loop of the gauge, back out through this harness, down this harness to this eyelet, which is on the starter solenoid. Everything's cool, except if something happens. Let's say if, in our instance, something happens in the alternator. The diode dies, it melts the solder, it falls against the case, it creates a dead short. Now we have a situation where the alternator is no longer charging, so juice is coming from the battery to the alternator because it is a dead ground. Okay, it goes right through here. Our electricity now is going back through here, back through our gauge, this big old wire here I've unhooked, back through that, back through this harness, out here, through this wire to the alternator. We've got a toaster here when that happens, folks, and it's not a pleasant one because this toaster knows no limits. So what starts happening is our piece of bread, that's what this wire turns up to being, is a piece of bread. It gets red hot and it starts melting. Okay, now let's follow this. We got a dead short here, and so our wire is going to get hot, and it's going to go up this harness, and it's going to be hot, 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 all the way down this harness, all the way up under the dash, through our amp gauge, back through the harness, back through this harness, and to the battery. Let's see, where am I lost? Here, back to the battery. So that big wire now is a toaster. It is hot. So best case scenario, we burn our wiring harness. Worst case scenario, we burn the car up. The way to stop this, if this ever happens to you, you've got to unhook the battery, either the positive or negative. I'd recommend the negative post, but at this point, you've got to break one of the posts. You got to break the connection, unless you happen to have a fusible link. Now, I don't know when these were invented, but they started showing up on cars in the 70s. And basically, it's like a fuse right here in your fuse block. It's just like that. And it does the same thing. But this wire melts before the wire we want to melts. In other words, this will carry the current that the alternator is producing to the battery. It'll carry the load, but should there be a dead short somewhere in the system, in our case the alternator, this will be the first thing to burn. It disconnects the battery on its own. Now, I personally had, not this particular Mercury, but another Mercury that we were driving before this Mercury. I had that vehicle do this to me, and luckily I was on the road, it was dark, I was able to yank the battery cable in two, and I saved the car. I ruined the wiring harness, but I saved the car. So when I restored this car, I took provisions that if that should happen, what am I going to do? How am I going to save myself? Well, I got to thinking, I'm going to put a fusible link, and I'm going to put it somewhere in this wire that carries the current. In my situation, you could put it down here in the alternator area, but that's down here on the side of the engine where it's hard to get to. And I opted to put it up here, which we'll show you here in the car here pretty soon. I opted to put it right here over by the voltage regulator, under the horns, where it's kind of easy to get to. I cut this wire and I just kind of put it in here in a loop so that I didn't destroy the harness other than just cutting this one wire and putting this in the system, just in case something should happen. Well, it happened. And that's why I'm telling you, it's not a matter of if it happens, it's going to happen. And it happened to me a couple weeks ago when Dee and I were all dressed up, ready to go out to actually my 45th high school graduation. Anyway, we were driving the vehicle, the engine started coughing, it completely went dead. We lost the air conditioner, the engine, any power. I looked down and my amp gauge showed a complete discharge. It was discharged. And I thought, uh-oh, I better look for smoke, smell for smoke. Luckily, there was no smoke. Pretty soon, the amp gauge came back to neutral. I had power, my engine was running, and I revved the engine and I got no movement out of the amp gauge. It didn't charge, didn't discharge, so I told Dee, I think our alternator died. Let's drive home and get the other car because it's going to be night, we'll need lights. So we did. The next day I investigated. As I told you, I opted to put it where it was sort of handy. It's not, you know, the alternator's over there. It's not real handy any place. But I put it over here. Here's your voltage regulator right here. We have a white paper down here to help show. Here's the voltage regulator. And I put it in the connection I showed you on the bench. There's the connection there. And there's where I cut the wire, there and there, and put in my fusible link. You notice how that fusible link has been burnt?
So it did the job it was designed to do.
It did the job it's designed to do. You notice the rest of the harness is fine? We smelled no smoke. Everything was cool. Saved the car, saved the harness. We didn't even smell smoky. Everybody's happy except now I have to fix it.